Hello, we are Pivot UAV from Palos Verdes High School. In the next few minutes, we will go through all our preparations for the 2019 AUVSI SUAS competition. Experience, roles, and responsibilities. Pivot UAV would like to proudly introduce the members of our team.
Hi, I'm Jim Campbell. This is my first year on the Pivot team, and I will graduate in 2021. During the year, I worked on the delivery system and will be a manual mission planner crewman on the flight line.
Hello, I'm Aidan Forsey. This is my second year on the Pivot team and I will graduate in 2021. During the year, I was in charge of the delivery system and will be the safety pilot on the flight line.
Hi, I'm Paige Forte. This is my first year on the Pivot team and I will graduate in 2022. During the year, I was working on the hardware sub-team and unfortunately will not be on the flight line.
Hi, I'm David Maemoto. This is my first year on the Pivot team and I will graduate in 2022. During the year, I was working on the delivery system and will be an image manager on the flight line.
Hi, I'm Allison. This is my second year on the Pivot team and I will graduate in 2021. During the year, I was working on the software sub-team and on the flight line will be an automated mission planner crewman.
Hi, I'm Eric Park. This is my fourth year on the Pivot team and I'll graduate in 2020. During the year, I was working on the ground station sub-team and will be on the mission planner crewman on the flight line.
Hi, I'm Toby Park. This is my fourth year on the Pivot team and I will graduate in 2020. During the year, I was in charge of the hardware sub-team and will be the interop manager on the flight line.
Hi, I'm Wesley Park, and this is my third year on the Pivot UAV team. I will be graduating this year in June. During the development phase, I was the team captain, and on the flight line, I will be the safety manager.
Hi, I'm Cassie Pheiffer. This is my second year on the Pivot team and I will graduate in June of this year. During the year, I was working as a software captain and will be the automated mission planner crewman on the flight line.
Hi, I'm Cassie Pheiffer. This is my first year on the Pivot team and I will graduate in June of 2021. During the year, I was working on the software sub-team and I'll be the image manager on the flight line.
Hi, I'm Nikita Swatek. This is my second year on the Pivot team and I will graduate in June of 2020. During the year, I was working on data transmission and receiving, and at competition, I will be the antenna manager.
System overview and planned tasks. The Condor 2 has experienced slight modifications and improvements for the competition in 2019. We shall proceed to explain enhancements made to the drone along with its basic components to completely describe the state of the Condor 2. The Condor 2 is controlled by the Raspberry Pi and Pixoc 2. The micro receiver Dragon Link connects to our controller, the DX6i, which is modified with the V3 Slim Dragon Link, so that the safety pilot will not lose connection with the Condor 2, while the bullet antenna ensures a secure connection to our ground station computers. We have 2 GPSs for redundancy, in the case that one should fail. The team's ground station is equipped with a computer designated for Mission Planner, a computer designated for the team's automated mission planner, a computer for the team's image managing program, 2 antennas that receive signals from the copter and the UGV respectively, and, of course, a power supply. Our team members will be stationed between the various computers with 3 at the IMP, 2 at the MMP, 2 at the AMP, 1 at the antennas, and our safety pilot. Autonomous flight. Will attempt. Confidence level, high. Waypoint capture, will attempt. Confidence level, high. Obstacle avoidance, will attempt. Confidence level, high. Image recognition, will attempt. Confidence level, medium. Autonomous detection, will not attempt. Airdrop, will attempt. Confidence level, medium. UGV delivery, will attempt. Confidence level, medium. Interoperability, will attempt. Confidence level, medium. Developmental testing. The team conducted multiple tests and improvements to the Condor 2 throughout the year. In the next few minutes, you will view the results of our team's efforts. Autonomous flights have been fairly successful this year. A few common causes of failure include GPS failure, thermal stress of wires, insufficient amount of battery, motor malfunctions, as well as throttle malfunctions. This table shows 9 entries for the same flight course. The columns show the difference in actual waypoints, the entered waypoints, latitude, longitude, altitude, as well as the sum distance. The motors on the Condor 2 require 250 watts of power per motor. Seeing how there are 8 motors, this means that 2,000 watts are required to power the Condor 2. If we include other components, this number is then increased to 2,100 watts. Using this number, we are able to theoretically calculate the values listed on the table. Modifications from last year's program have been made due to the removal of moving obstacles. Accuracy has increased significantly because of this, and the team is very confident with our automated mission planner's ability to avoid the obstacles. In the table, successful deployment is considered the successful release of the UGV from the Condor 2. The distance from the drop target is the distance from the UGV's point of ground contact and the planned point of ground contact. The distance from the final target is the UGV's distance from its final destination. The last 2 columns are measured in feet. The distance from the final target are checked in at very high numbers due to inconsistencies in the autonomous capabilities of the UGV. In the table, successful deployment is considered the successful release of the UGV from the Condor 2. The distance from the drop target is the distance from the UGV's point of ground contact and the planned point of ground contact. The distance from the final target is the UGV's distance from its final destination. The last 2 columns are measured in feet. The distance from the final target are checked in at very high numbers due to inconsistencies in the autonomous capabilities of the UGV. Mission testing. The team completed full mission tests in order to test our overall confidence in a real, full mission setting, just as it would be done at a competition. The following reveals the data of our results. 3 mock mission tests were conducted. All scores on the table are represented as percentages. Because image detection is still a work in progress, the scores are lower than the team would have hoped. As the team has analyzed, we are most confident in our timeline, autonomous flight and interoperability, and our obstacle avoidance. With the improvements the team has made throughout the year, our biggest improvements are towards the distance the copter can travel, minimal improvements with our obstacle avoidance, our waypoint accuracy, and our operational excellence. The team is still rigorously making improvements to its drop mechanism and UGV, as well as the image detection that will be making its debut shortly. Thank you for listening to our flight readiness review for the 2019 AUVSI SUAS competition. We look forward to seeing you in June.